A sweet and short introduction to sine integral function. So basically, in this video, we will talk about some definitions of the sine integral functions and an alternative sine integral function, yeah, and their derivatives, their integrals, and one new sinc function, and the relation between capital SI and small SI function. Yeah. So let's begin. First of all, let us here's the definition of the sine function, sine integral function. This is basically defined as the integral from 0 to z of sine x by x dx. You might have known that the integral of sine x by x does not really exist with elementary functions, so that's why we had to define a non-elementary function capital S f z. And similarly, corresponding to this one, there's another function as well, which is basically integral from z to infinity sine x by x dx. Now, the reason behind putting a negative sign over here is because if we put a negative sign over here and write this as small si of z, yeah, if we put negative sign over here, when we are differentiating, we will get the exact same function in both cases. Here also it's sine x by x, in other also we will just get sine x by x. So that is the reason we put negative sign over there. Yes, small si of z, also sine x by x. Now you can see that why we get the same function basically from we can differentiate this and then use the Leibniz formula or Feynman's rule of how we can differentiate an integral at the same time. So that's why this negative sign basically conjures the function that's inside. Yeah. So that is our definitions. Now let's see a property that connects these two functions. Yeah. So basically we know that. Let me try to find capital SI of z minus small si of z. Yeah, and then we need to get this as pi by 2. Yeah, we know that capital Si of z is just integral from 0 to z sine x by x dx, and then the minus and minus sign becomes plus, and integral from z to infinity sine x by x dx. Now if we add these two, we get integral from 0 to infinity sine x by x dx, and we know that this is a well-known integral whose answer is known to be pi by 2. So that is it. And if you want the explanation for this, you can just search in YouTube about integral from 0 to infinity sine x by x, and there's a lot of videos on YouTube already on this function, so it's 5 by 2. Now next, so now we know that even though we get sine x by x as the answer in many cases, we know that this is not really well defined at x equals to 0, and we need to take limit. So that's why for the derivative of capital S of z or over here, what we can do is we can define another function, sinc function, which is basically sine x by x itself for all the values that are not equals to 0. Yeah, if it's equals to 0, we use the limiting value, which is 1. Yeah, so if we define it like this, then it will be like define at all the points, and so that we can also write derivative of capital Si of x as sinc function. Yes. Now for the integral, now the integral part, it's also not too hard, just some basic ideas. So we have to find integral of capital Si of x dx. Is it? Yes. So we know that first of all, let's take this as u and 1 as v. So capital Si of x, integral of 1 is x minus integral of derivative of Si is sine x by x. Yes, and note that I'm not using sinc over here because sine x by x is deal with then sinc, and then integral of 1 is x dx, and the x cancels out, so we are left with x Si of x, and then minus Integral of sine is minus cos, so minus minus becomes plus cos x plus c. So this is the integral of capital SFS, and similar will be the integral of small SFX as well. So cos x plus x SIFX plus c as well. So these are the things that basically introduce the sine integral function. And after this definitions, we are almost ready to deal with the integrals involving sine integral function. So hope that this makes sense. And also while doing the problems, you might also it might also be necessary to change this definition in the following way. Let's say if we have capital S of g as integral from 0 to g of sine x by x, what you can also do is to change the limits into numbers. You can make a substitution. Let's say t equals to x by z. If you make the substitution, basically this will go from 0 to 1. In place of x you will have sine of gt, in place of x you have gt, and then in place of dx you have g dt. So gc cancels out, and this can be written as integral from 0 to 1 of sine of gt by t dt. Yes, this is also an useful definition, just a modified form. And yeah, you can use this to simplify problems. So I hope the things are clear. We first dealt with definition of sine integral function and the small sine integral function, and the relation between them, and sinc function, derivative of SI, and integral of SI. So that was it for this video. Hope you enjoyed the video. Thanks for watching, and look forward to seeing in the upcoming videos too. Be with me and keep enjoying.